Dobre, na to? Počúvajte, tá hodinová verzia, počúvaj, mňa to nenapadlo. Ja som vám nechal hrať tú sračku, soračet. Don fantastický páč o 43 mesiacov díkes, čo sa vyskytuje raz v každej minúte, dvakrát v každom momente, ale ani raz v roku. Strom, 100%. Kde to 43 mesiacov výstav díkes, bráško? Google, ty čo, prasiači, kam si išiel, čo? Už som sa ešte kávu, čo? Idem si pre kávu, či nejdem? Ukáž? Čo guliček? Víš si laškať? Na tričko najlepšie. No jasné, presne tam. Dobre, poďme tu, počkaj, napíšem správu a môžete si pozrieť. Čiže mám byť zajtra o 10:00. Mala by byť, no. Počkajte, sekundičku. Dcera hviezda je tou největší ve vesmíru.
A k ní slabá Pepega tak ako každý rok dáš na Vianoce misa mrcar ale na permadev. Další challenge pomek čo povieš, UFO kontakty forever, kto súhlasí jedné do chatu.
Nie. A nie je to každý rok na Vianoce, no na nový rok, ty Pepega. Či nebude to na hardcore. To by bolo navždy, chápeš? To by bolo navždy.
Universe. And why is it that large? And what are stars anyway? Things that would like to be stars. We begin our journey with Earth, not to learn anything, just to get a vague sense of scale. The smallest things that have some star-like properties are large gas giants or sub-brown dwarfs, like Jupiter, the most massive planet in the solar system. 11 times larger and 317 times more massive than Earth, and more or less made of the same stuff as our Sun. Just much, much less of it. The transition towards stars begins with brown dwarfs, failed stars that are a huge disappointment to their mums. They have between 13 and 90 times the mass of Jupiter. So even if we took 90 Jupiters and threw them at each other, although fun to watch, it wouldn't be enough to create a star. Interestingly, adding lots of mass to a brown dwarf doesn't make it much bigger, just its insides denser. This increases the pressure in the core enough to make certain nuclear fusion reactions happen slowly and the object glow a little. So brown dwarfs are a sort of glowy gas giant that don't fit into any category very well. But we want to talk about stars, not failed wannabe stars, so let's move on. Main sequence stars. Once large gas balls pass a certain mass threshold, their cores become hot and dense enough to ignite. Hydrogen is fused to helium in their cores, releasing tremendous amounts of energy. Stars that do that are called main sequence stars. The more massive a main sequence star is, the hotter and brighter it burns, and the shorter its life is. Once the hydrogen burning phase is over, stars grow, up to hundreds of thousands of times their original size. But these giant phases only last for a fraction of their lifespan. So we'll be comparing stars at drastically different stages in their lives. This doesn't make them less impressive, but maybe it's good to keep in mind that we'll be comparing babies to adults. Now back to the beginning. The smallest real stars are red dwarfs, about 100 times the mass of Jupiter, barely massive enough to fuse hydrogen to helium. Because they are not very massive, they are small, not very hot, and shine pretty dimly. They are the only stars in the main sequence that don't grow once they die, but sort of fizzle out. Red dwarfs are by far the most abundant type in the universe. Because they burn their fuel very slowly, it lasts them up to 10 trillion years, 1,000 times the current age of the universe. For example, one of the closest stars to Earth is a red dwarf star, Barnard's star, but it shines too dimly to be seen without a telescope. We made a whole video on red dwarfs if you want to learn more. The next stage are stars like our Sun. To say the Sun dominates the solar system is not doing it justice, since it makes up 99.86% of all its mass. It burns far hotter and brighter than red dwarfs, which reduces its lifetime to about 10 billion years. The Sun is 7 times more massive than Barnard's star, but that makes it nearly 300 times brighter with twice its surface temperature. Let's go bigger. Small changes in mass produce enormous changes in a main sequence star's brightness. The brightest star in the night sky, Sirius, is 2 solar masses with a radius 1.7 times that of the Sun, but its surface is nearly 10,000 degrees Celsius, making it shine 25 times brighter.
Yeah,
Burning that hot reduces its total lifespan by 4 times to 2.5 billion years. Stars close to 10 times the mass of our Sun have surface temperatures near 25,000 degrees Celsius. Beta Centauri contains 2 of these massive stars, each shining with about 20,000 times the power of the Sun. That's a lot of power coming from something only 13 times larger, but they'll only burn for about 20 million years. Entire generations of these blue stars die in the time it takes the Sun to orbit the galaxy once. So is this the formula? The more massive, the larger the star. The most massive star that we know is R136A1. It has 315 solar masses and is nearly 9 million times brighter than the Sun. And yet, despite its tremendous mass and power, it's barely 30 times the size of the Sun. The star is so extreme and barely held together by gravity that it loses 321,000 billion tons of material through its stellar wind every single second.
Yeah, Betty.
Stars of this sort are extremely rare because they break the rules of star formation a tiny bit. When supermassive stars are born, they burn extremely hot and bright, and this blows away any extra gas that could make them more massive. So the mass limit for such a star is around 150 times the Sun. Stars like R136A1 are probably formed through the merger of several high-mass stars in dense star-forming regions and burn their core hydrogen in only a few million years. So this means they are rare and short-lived. From here, the trick to going bigger isn't adding more mass. To make the biggest stars, we have to kill them. Red giants. When main sequence stars begin to exhaust the hydrogen in their core, it contracts, making it hotter and denser. This leads to hotter and faster fusion, which pushes back against gravity and makes the outer layers swell in a giant phase. And these stars become truly giant indeed. For example, Gacrux. Only 30% more massive than the Sun, it has swollen to about 84 times its radius. Still, when the Sun enters the last stage of its life, it will swell and become even bigger, 200 times its current radius. In this final phase of its life, it will swallow the inner planets. And if you think that's impressive, let's finally introduce the largest stars in the universe, hypergiants. Hypergiants are the giant phase of the most massive stars in the universe. They have an enormous surface area that can radiate an insane amount of light. Being so large, they're basically blowing themselves apart, as gravity at the surface is too weak to hold on to the hot mass which is lifted away in powerful stellar winds. Pistol Star is 25 solar masses, but 300 times the radius of the Sun, a blue hypergiant aptly named for its energetic blue starlight. It's hard to say exactly how long Pistol Star will live, but probably just a few million years. Even larger than the blue hypergiants are the yellow hypergiants. The most well-studied is Rho Cassiopeia, a star so bright it can be seen with the naked eye, although it's thousands of light years from Earth. At 40 solar masses, this star is around 500 times the radius of the Sun and 500,000 times brighter. If the Earth were as close to Rho Cassiopeia as it is to the Sun, it'd be inside it and you would be very dead. Yellow hypergiants are very rare though, only 15 are known. This means they're likely just a short-lived intermediate state as a star grows or shrinks between other phases of hypergiantness. With red hypergiants, we reach the largest stars known to us, probably the largest stars even possible. So, who's the winner of this insane contest? Well, the truth is, we don't know. Red hypergiants are extremely bright and far away, which means that even tiny uncertainties in our measurements can give us a huge margin of error for their size. Worse still, red hypergiants are solar system-sized behemoths that are blowing themselves apart, which makes them harder to measure. As we do more science and our instruments improve, whatever the largest star is will change. The star that is currently thought to be among the largest we've found is Stephenson 218. It was probably born as a main sequence star a few tens of times the mass of the Sun and has likely lost about half its mass by now. While typical red hypergiants are 1,500 times the size of the Sun, the largest rough estimate places Stephenson 218 at 2,150 solar radii and shining with almost 500,000 times the power of the Sun. By comparison, the Sun seems like a grain of dust. Our brains don't really have a way of grasping this kind of scale. Even at light speed, it would take you 8.7 hours to travel around it once. The fastest plane on Earth would take around 500 years. Dropped on the Sun, it would fill Saturn's orbit. As it evolves, it will probably shed even more mass and shrink down into another hotter hypergiant phase, accumulate heavy elements in its core, before finally exploding in a core collapse supernova, giving its gas back to the galaxy. This gas will then go on to form another generation of stars of all sizes, starting the cycle of birth and death again to light up our universe. Let's make this journey again, but this time without the talking. The universe is big. There are many large things in it. If you want to play a bit more with size stuff, we have good news. We've created our first app, Universe in a Nutshell, together with Tim Urban, the brain behind Wait But Why. You can seamlessly travel from the smallest things in existence, past the coronavirus, human cells,
Môj penis je väčší? Samozrejme, že je, bráško. Huge penis.
And dinosaurs.
Že by som si niečo pozeral, popravde. Čo to je také? O firme, ktorá má dodať vakcíny pre celý svet. Chcem to vidieť. Nie chcem vidieť vôbec. O vakcínach. Hej, jebem ich. Pfizer. Jaké veľké objekty a niekto zabije napríklad pojebaných hmyz? Niekto zabije pojebaných hmyz? No. Najhoršie je na to, že sa nič... Ja by som musel vedieť o vesmíre všetko. Bohužiaľ. Bohužiaľ na to nemáme. Čo je ešte dobre vedieť? Čo by sme si potrebovali čet? How long could you survive on each planet without space suit? To nechcem vidieť. Rage Quiz 21 mesiacov. Ďakujem pekne, bráško. Korona je fake. Jak sa máme? Máme dobre. Čo ty? S-portal uspánu. Nechcem to vidieť. Díkes. Maz nás tam zoberie jedného dňa, neboj. To už dávno nebudeme žiť ani my, ani on. Však on ostal depresívny úplne potom, keď povedal, že možno sa nikdy nepostaví na Mars. Že je to veľmi pravdepodobné. Hlavne, že on by tam aj chcel ísť, ale nemá komu zveriť ten chod všetkých vecí, ktoré robí on. Že takže nepravdepodobné, že on sa tam niekedy pozrie. Že keby má niekoho, kto by ho zastúpil v tých veciach, ktoré robí, takže by išiel. S tou prvou posádkou povedal. Mass Effect 1 na 3? Nikdy som hral Mass Effect 3, nikdy. Ale ti hovorím, najbližšie chceme dohrať ten Minecraft chalani. Možno dáme sem tam, ja neviem, možno dohráme ten Assassin's Creed, jak ma to bude dotedy baviť. A chceme zahrať potom Rust versus Chat. To bude sranda pre vás. To bude srandička. To bude dobre. To budú dobré streamy isto. Takže máme veci, čo chceme robiť, aby sme sa bavili, Chat. Prichádzajú sviatky, pičovinečky, stále tu je korona, stále sme zamknutí, takže máme čo kúkať, kalavši. Máme čo kúkať, máme čo hrať. Takže som rád. Na budúci rok bude Mass Effect Trilogy Remaster. To môžeš garantiť najlepšiu vesmírnu hru, fakt? Ja by som si chcel pustiť teraz Mac Millera alebo niečo, ale bohužiaľ nemôžeme. Kúku gaškony, čo to je zač? CSGO cheater trolled by fake cheat software, to nechcem vedieť. Ja by som povedal niečo o vesmíre, alebo niečo veľmi zaujímavé, čet. Most incredible things the Hubble telescope has ever captured, to nechcem vedieť. Wormholes, červie diery vysvetlené, rozbitie časopriestoru. Oh shit, to je mohlo byť dosť dobré. Najlepšia vesmírna hra Dead Space. Ja som hral Dead Space dvakrát na streame a dvakrát som skončil na rovnakom mieste a dvakrát ma to prestalo baviť na rovnakom mieste. To bolo, ja neviem, pre mňa, ja neviem, že všetci, strašne veľa ľudí hovorí, že obľúbená hra Dead Space a najviac to chvália a mňa to tak absolútne nebavilo. Budúci rok v útorok majú vypustiť nový teleskop, najvyšší na svete. Budúci rok v útorok. Timelines of the Future sme videli. To bola jebička. 2 videá sú také. Make me no document. Však Dead Space je v podstate ten štýl hry jak Resident Evil. To neviem. Resident Evilom bavili ako kot. Končíme? Nie, ešte ideme hrať, chalani, ideme hrať. Budeme tu ešte hodku a pol, 2 možno. Dáme na chvíľku, ideme vylepšiť build do Async. Som musel ešte niečo vidieť, neviem čo. A neviem čo. Hral som niekedy Shadow of War. Iba ten prvý diel som hral. Ja vlastne nemôžem ani Metalliku pustiť nič, že? Ty víš, že tmavé, hnusné miesto. Mlieko, biely jed alebo zdravý nápoj. Či chcete vidieť niečo o mlieku? Či čo by vás zajímalo? Počkaj, idem sa pozrieť, čo tam je. Čo to také je? 12021 Human Era kalendár. How large can bacteria get? Life and size 3.
Tady máš ty prachy.
Čo to je také zaujímavé? Zajové posledné čauko. Chceš, čo ťažíš krypto? Ako sa to volá? Čo si vravel? Vtedy sa to ťaží za teba. Ďakujem. Neťažím žiadne krypta, starec. Nemám tušenia. Jak to funguje, takéto vecičky. To si ma asi nejako zle počul, alebo niečo, alebo sme sa len o niečom bavili. Teraz som jebol margotku a teda 400 kalórií, to je halus, no a... To je dobrá večera. Minulosť, do ktorej sa nikdy nemôžeme vrátiť.
Kámo, já som hneď už asi pol roka dozadu furt rozmýšľal, že však ja Luxa poznám, však ten hlas som niekt počul, boha, já som vedel, že to je Lukas, však som s ním pracoval, veľký šéfko.
Hej, si s ním robil? Ty si blázen. A ty si ho ako poznal na streame, že s ním hrávam a nevidel si, že to je on? Hej, kokot. Chcel by to nejaké highlighty z toho, čo sa dneska dialo, čo tam všetko bolo. Migo, ideš s nami na GoTest, Goti, OK, covidu toho 17 novembra, uvidím, neviem, či tu tedy budem. Ja tomu nerozumiem. Čau, bude sa zde na Mike Tyson? Hej, tam, ako isto si posadím, 100 € dám na Tysona. Jaký tam je kurz?
Tady máš ty prachy.
1000 km kábelku hviezdam. Neutronové hviezdy, najextrémnejšie objekty, protijed k nespokojnosti, preľudnenie a Afrika, ako pohnúť slnkom, hviezdne motory. Prečo vráskavce obrovské nedostávajú rakovinu? Peťov paradox. Vajce bolo dobrý príbeh, to bolo po piči, to sme kúkali. Miliardová mravčia megakolónia. Keď bude nové Call of Duty? Neviem, chalani, dáme ho ale na posledne, možno dáme až na plejku, keď príde, keď bude mať plejko, že by som mohol zahral na joysticku. Uvidíme. To má čas, chalani, má čas. Mám čo hrať teraz. Mám kopec hier, čo ma baví a... Hej, všetko je v klídku. Krátky dokument o vesmíre. Tourin 10 Koukni na hru Region of Nights. Poznám to. My sme to aj hrali so Žolom.
So, let's start with a couple of questions here about the science that you're doing on board the space station. So, what kind of research are you doing in space that we can't do anywhere else?
That's a great question, Mark. You know,
Najnebezpečnejšie veci vo vesmíre. Podivné hviezdy. Počujete, jak chrápe? Počúvaj to. Chvíľočku. Počujete to? Či nepočujete? To je Google proste. Rozkysnutý cez gauč a chrapčí jak prasa. 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 Nič, a nepočuje už. Ho zobudíš? Čo ho budíš? On zle počuje už. Už ho nezobudím tak ľahko. Minule pil záchod na vodu. Hovorím Google, prestaň. A no má nahlas. A nič. Proste len pil vodu. ale podľa mňa, on to hrá, lebo niekedy iba cuknem, zašuštím papierikom a hneď vie. On keby naschvál ignoroval kokot. Ale šušneš hociakým jedlom a už hneď pozrieš, že kokot čo? Že tu je nejaké jedlíčko? Že to by som si dal? Ale ideš na vodítku a hovorím, že Google, úplne, a vždy idem od ticho, že najskôr Google a vždy zhlasňujem, tak nič, ignoruje. Alebo nepočuje možno. Co si říkal? Naschvál som ťa ignoroval. OK, ty ideš kamoško na sekundu timeout. Tebe dneska mačka preskočila susedom omylom a ich dvaja vlčiaci ju roztrhali na kusy? Môže byť. Mačka to má za sebou, hovoríš. Naša tam skákala. Soráč starec. Jak je to pravda soráč, ale isto to je troll. Jak nie, tak je soráč, ale... Hej, furt je to mačka. Bitcoin na 14 900, piči, ako to teraz zdaniť? Tak je, keby ho predávaš za 6 000, rovnako, bráško. How big is the moon? Dobre, na to nemyko nič. Our home in space. How evolution works. Si sám vo vesmíre. Pred 6 rokmi video. To správne sa mi je, počkaj, to sme už videli. Is reality real? Teraz som ukázal Black Mirror chat a bola, týko tam bol to pekne nechutný diel. Neviem, či si videli Black Mirror, ale bol tam teraz diel, kde sa babe narodila dcéra a furt sa o ňu bála, tak sa zapísala o nejaký program, ktorý bol v beta verzii, že nič za ňu neplatila. Oni jebli injekciu nejaký čip do hlavy a ona cez tablet videla všetky životné funkcie, čo vidí, kde sa nachádza GPS-ku, také veci. Modček, chalani, ja dám ten emot do piče, pravde prvá vec. Odkedy fungujeme len na otázkach a odpovediach do piče? Však normálne, čo nás zaujíma, to proste povieme na našom streame, nie? Vy pepeky, choď daj do piče ten emotbex. Dáme ho preč. Dám ho do playlistu, mi je to jedno. Skúrim... Trtkali ju, čo? Najlepší emot? Triggeruje ma to jak kokot. Modček. Dobre, ešte jedno video si pozrieme aspoň. Čo vedej? Koniec vesmíru, vytvorenie väzenia pre ľudstvo. OK, 8 minút. Je tam české titulky alebo není? Titulky angličtina, je tam české? Čeština. Let's go.
Space travel is the most exciting and challenging adventure humanity has ever undertaken. But in an irony of history, we may stop ourselves from going into space the more we do it. With every rocket launched and with every satellite deployed, we're creating a trap for ourselves that gets deadlier and more dangerous every year. If it's ever activated, it could end the space age and trap us on our planet for decades or even centuries. Getting something into space is incredibly hard. To do so, you need to move very, very fast, at first straight up to leave the atmosphere, then sideways to begin a sort of circling around the Earth, still very, very fast. If you do that successfully, you can enter a low Earth orbit. And once in orbit, it's very hard to get out of orbit. Unless you have energy to spare, you're sort of locked in here, falling around the Earth forever. That's great for things we want to stay up, like space stations and satellites. And so we moved the majority of humanity's space infrastructure to this place, just a few hundred kilometers above the surface. Just high enough so that the atmosphere is so thin that orbiting things can stay up for centuries before air resistance can slow them enough to bring them back to Earth. But this is also the source of our deadly trap. Rockets are really metal cylinders that keep big piles of fuel in place. Whenever a portion of the fuel has been spent, the empty tanks are dropped to make the rocket lighter. Some parts crash down to Earth or burn up in the atmosphere, but most of the useless rocket parts stay up and begin to orbit the planet. After decades of space travel, low Earth orbit is a junkyard of spent boosters, broken satellites and millions of pieces of shrapnel from missile tests and explosions. Right now, we know of around 2,600 defunct satellites, 10,000 objects bigger than a monitor, 20,000 as large as an apple, 500,000 pieces the size of a marble, and at least 100 million parts so small they can't be tracked. This debris is moving at speeds of up to 30,000 kilometers per hour, circling Earth on crisscrossing orbits multiple times a day. Orbital speeds are so fast that being hit by debris the size of a pea is like being shot by a plasma gun. On impact, the debris vaporizes, releasing enough energy to punch holes straight through solid metal. So, we've covered the space around our planet with millions of deadly pieces of destruction. And we also put a $1 trillion global infrastructure network right in the danger zone. It performs critical duties essential to the modern world: global communication, GPS and navigation, collecting weather data, looking out for asteroids, and all manner of scientific discoveries. Things we would miss very much if they suddenly went away. If just one pea-sized bullet hits one of our 1,100 working satellites, it will be destroyed instantly. 3 or 4 satellites are already being destroyed this way every year. As the number of satellites and the amount of junk in orbit is expected to grow tenfold in the next decade, we're approaching a tipping point. But the worst thing in space is not tiny pieces of junk. The worst thing would be an unstoppable chain reaction that turns a lot of non-junk things into junk. For example, if 2 satellites hit each other in just the right way. If satellites collide, they don't stop and fall out of the sky. It's more of a splash than a crash. Orbital speeds are so fast, solid pieces spray right through each other, transforming the 2 satellites into clouds of thousands of little things still fast enough to destroy more satellites. This could trigger the slowest and most destructive sort of domino effect, a collision cascade. Like a shotgun spray, each collision creates more bullets. What was once a single tiny target, very unlikely to hit anything, becomes a wall of destruction, hungry to make more. As more and more satellites are destroyed, the destruction accelerates exponentially, eventually destroying everything parked in orbit. But space is very empty, so the first few collisions may take a long time. By the time we realize what's happening, it's too late. 1 year, 1 satellite is destroyed, and that's no big deal. The next year, 5. The year after, 50, until there's nothing left. The situation in orbit is rapidly worsening, and we may already be past the point of no return. Within 10 years, space around Earth may no longer be viable for long-term satellites or rockets. The worst-case scenario is horrifying. A debris field made of hundreds of millions of pieces, many too small to track, moving at 30,000 kilometers per hour. It would effectively create a deadly barrier around Earth, possibly too dangerous to cross. Dreams of moon bases, Mars colonies, or space travel at all may be set back centuries. And the loss of our space infrastructure would send some of the technology we rely on daily back to the 1970s. But it might not be too late to clean up our mess. While the space industry has become better at avoiding space junk, it's still growing fast and occasional weapon tests don't help. So there have been a couple of wild but also serious suggestions about how to quickly remove as much deadly space junk as possible without creating more in the process. Lots of ideas are being thrown around, and some of the most seriously considered involve capture and return missions, which are being tested now. One method involves meeting a piece of junk in orbit with a small satellite loaded with a net. Once caught, a small rocket could be used to bring it down towards Earth. Targets too large for a net might be instead caught with a harpoon on a tether. Instead of firing a rocket, the cleaner would deploy a large sail to produce atmospheric drag and accelerate orbital decay. And there are lots of other wild sci-fi sounding proposals too. Some might use giant electromagnets. These magnetic tugs work by pushing on the magnetic components inside satellites that they use to stabilize and orientate themselves in Earth's magnetic field. These may be safer and more reliable than nets and harpoons because they never have to make contact with the junk they're handling, so there's no risk of accidentally breaking up their target into more junk. As for the tiniest bits of junk, lasers might be the key to vaporizing them entirely. Satellites with lasers wouldn't need to visit their targets, they can shoot them from far away. Large objects can't exactly be shot down, but lasers can be used to ablate them or burn tiny amounts of material off the side to push the junk to a safer orbit. Whatever technology we use in the end, we better start doing something soon, before 100 million bullets become a trillion and the trap is set. If we don't act, our adventure in space might end before it's even begun. If our days of dreaming about space exploration might be numbered anyway, we better put them to good use. One of the things we most like to spend our time on is learning more about our universe. And
Koľko ten vesmír je jeba. Počuť, ja ti hovorím, že neexistuje chvíľa, kedy proste nechceš si to pozrieť. Niečo o tom. Dajú sa tam dať titulky, ukáž? Elon Musk, ukáž?
3, 2, 1.
3000 zhľadnutí.
Yeah, I wouldn't worry too much about the space junk.
Počkaj. To bude kvalitou, dúfam, že tam nebude nejaká cicina alebo niečo.
1, 0.
Minútu iba.
Yeah, I wouldn't worry too much about the space junk thing. I mean, actually, we should worry about ourselves creating the space junk, but at the altitude in question, there's really not a lot out there. So we're talking about something about the 1100 kilometer level, and there's just not a lot up there. The thing we need to make sure of though is we don't want to create any issues. So we're going to make sure that we can deal with the satellites effectively and have them burn up on re-entry and have the debris kind of land in the Pacific somewhere. That's basically what we need to make sure of. Because I mean, the number of satellites we're talking about here ultimately is around 4,000. Actually, technically today, the discussion was 4,025, although there's probably false precision there, but that's kind of what we're thinking right now. And there's less than half that number in active satellites currently in existence. So it's more than double the number of currently active satellites.
Aj tak, vieš, to je teraz, ty kokot. Hej, nám to bolo ukázané s tou reťazovou reakciou, vieš, že keď sa to stane a keď sa to spustí, že to dokáže spôsobiť do píče. Black Mirror mi bol odporúčaný, alebo v prvom dieli Politik a prasa, ma to vôbec nezaujalo, sú ďalšie diely lepšie. A hlavne úplne o niečom inom, vieš, oni vôbec na seba nenadväzujú, takže ja napríklad teraz, ja to kúkam tak ten Black Mirror, že iba si scrollujem medzi tými dielmi a ktorý má zaujímavý príbeh, ktorý len si pustím. To je hodinový film, ja dám popri tom bicykel, zacvičím si a pičoviny, vieš. Takže isto si pozri, čo sú tam také tie, akéby blízka budúcnosť nejaká, vieš, o tej virtuálnej realite a tie čipy a tak tam zaujímavé vedeli. Vedel si, že Bruce Buffer, UFC, ten čo uvádza zápasy, si zarobí ročne cca $1 milión? Môže byť?